Hey there, everyone. Today we're going to be having a war with ChatGPT. So, what we're going to be doing is we're going to have some questions. We're going to try to solve them on our own. And then we're going to see if ChatGPT could solve it even better than us. And if we could solve it better than ChatGPT. So, this is actually going to go like a war. So, first, we're going to do is we're going to go to leetcode.com and we're going to get one of the most popular problems from there. So, the first question is to sum. So it's pretty simple. What we're going to have to do is we have an array of integers, and let's suppose that they are nums, and we have an integer target. Okay. What we're going to do is return the two numbers such that they add up to the target. And these are some of the information that we need, and we're going to have to write the code. So let's just write the code for this problem right now. So I believe we could shift this up and you could see this code over here. What I'm going to do is I'm actually going to just go, whatever comes in my mind. So the first thing is we have this vector given and we have this target given. And the example here is like you have this array, which is 2, 7, 11, 15, and you have the target as 9. So you will have to find that if the two numbers could add it up to the target. So, and you have to return the indices of those. So you could see over here 0 and 1 are returned. These are the indices of 2 and 7. So these add up to 9, and that is our target. And that's the answer. So over here, you could see 3, 2, 4, and the target is 6. So of course, 1 and 2 add up to 6. So that's why the indices 1 and 2. Remember, indices start from 0. And over here, you can see that 6 is basically from 0 and 1. So this is the requirement of this question, and I'm going to write the code. Initially, what I would do is I would go for a for loop, and I would go the first round from 0. I would go I less than the numbers dot size function, and then we have the I plus plus. What we'd do now is we'd actually go for a next loop, an inner for loop that we could go, and I would just name it as j, which is equal to 0. J is less than nums dot size function, and would have j plus plus. Okay, now one thing that comes here is that we're gonna have these duplicates. We're gonna have two 0 0 at the start, and then we're gonna have to match it up with 1 1. So try to ignoring that, we'd have to do if I not equal to j, right? So if I not equal to j, then we're gonna see if the two numbers add up. So that's why we're gonna say if the numbers sub I plus the numbers sub j, if they add up to the target, so like that, what we could do is simply actually we have to return a vector int, okay, of the indices. So what we could do is we could create a vector up here, and we'll call it vector int the type, and we'll call it solution. Okay, and over here we'll just push back the numbers. So we'd say solution dot push underscore back, and the first number would be I, and then the second number would be j. Remember, this is just a solution that I'm solving. There's so many other kinds of solutions, but this is one of them. So solution I and j, and then what we're gonna do now is we're just gonna return the solution vector. So we'd say solution vector just returned. If we don't find something from this for loop, we could just return the solution vector as an empty vector. So something like that could be the solution for this problem. Let's submit this. First, let's run this and see if this result actually works. So it's judging, and it says it accepts the problem, and the runtime is 0 milliseconds. Okay, great. And of course, if I submit it, it would accept everything. So if I just copy this text, because it will lead me to this runtime of this, and it's like accepted and everything. But if I go back, let's go back here, and I want to give this same prompt to ChatGPT, and it's asking me, can you come up with an algorithm that is less than 0.0 of n squared time complexity? Now I know that this algorithm that I wrote actually has two nested for loops, meaning I'm using O of n squared, but it's challenging me if I could do it in n squared. But I'm not going to give this challenge to ChatGPT, that bonus point. I'm just going to give this simple question, and this was just a follow-up. So I'm just going to copy this, and I'm going to go to ChatGPT, and what I'm going to say is write me a simple C++ solution for the following. Okay, so we're just going to paste that in, and let's see what ChatGPT brings up. So let's see. Now we have here simple C++ solution, what we have is just a single for loop. Wow. So we'd even given the, the challenging part of that. So this means that this could work in O(n)'s time. Why? Because we have a, suppose it has a vector standard map, and it has the int num to index. And then what we could do is we basically get the complement. So this is a really good solution to this problem. And if I ask the runtime for this problem, so let me just explain what this is happening first, and then I'll tell the runtime. So what happens is that we just need a single for loop. We don't even need two loops, and that is basically slower. This is really slow. And one single loop, and this is getting the complement. So when we're getting the target, which is, let's suppose the target is 9, and then we'd have the num sub I. So we iterate from 0 all the way to the size. Remember that. And the first number is actually in the array 2. So we're to do 9 minus 2, and that is actually 7, and that 7 is in the complement. We actually put it inside of this map. So remember, a map is something which has a key and value. So we'd have to find if 7 already exists in there. If it does, then we just return the num to index of the 7, which is the index of 7 inside of the array, and as well as the current number, which is the 0th number index, and that would give us the result. So simple. And if not, we just insert that into our map, and if we didn't find anything from this for loop, we just return a null, an empty vector. So pretty simple, pretty great. And if I ask this, what is the runtime, I believe it's O(n) because we're not using anything else. What is the runtime? And for this solution, okay, so if I type this in, it would give me that the runtime is O(n). Awesome. And that is crazy. Okay, so next problem we're gonna jump to is the valid palindrome problem. Now you can see that I have solved this before, but it doesn't matter. I'm gonna go through it again, and I'm gonna explain the process I've done. So it says over here a valid palindrome. Now a palindrome is something which has the same sequence like in the beginning and at the end. So an example of a palindrome is something like race car. Now race a car is not a palindrome, but race car, the word, if I type it in somewhere, let me just get a text file. So if I type in race car, now you can see I could spell race car forwards and backwards the same. So RACECAR, and then if I spell it like this, RACECAR. So race car is a palindrome. Now there's some spaces here, and you want to remove these spaces, and you also want to remove these special characters. So it says over here about phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all alphanumeric characters. Alphanumeric characters means characters that are both there are alphabets, lowercase, uppercase, or numbers, not special characters. It reads the same forward and backward if alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome or false otherwise. Now these are some examples, and these are the constraints. So the solution that I came up with was actually having this public bool is palindrome string. So you can see that this string is passed in. This is already given. This is the solution that we wrote, okay? So the thing is, we got a clean string. We got to first clean this string that is, this ugly looking string. This is a man, a plant, a plan, a canal, Panama. Actually, these, commas and these, colon, these all are removed with this clean string method, and this is actually turning out to be a palindrome, which is crazy. So now what we're going to do is we're going to have a for loop that would iterate from each character by character. So we would check the first character, which is capital A, and it would say if this is a alphanumeric character. An alphanumeric character, remember, is a character which is either an alphabet, lowercase or uppercase, or even a number, and that condition is true. So we would just do to lower that C, and we'll put it in that clean string. At the end, we'll have this, string like this. So this loop does all of that for us. After that, what we would do is we'd have the left and the right declared for us. The left is basically the starting point from 0 index, and the right will be from here, which is from the A. So the right is clean string dot length minus 1. It would be from here, A, and the left would be from here, A. We're going to check if A equal to A, but we also have to have a while loop that says that left has to be less than right. It has to be less than right. So this is the while condition, and we have to check if the left equals to right. But in case we not if they're not equal. So if say if the clean string sub left not equal to the clean string sub right, we'll return false immediately. And if it is, we'll just, left plus plus, meaning we're going to increment left by 1, and right minus minus, we're going to decrement right minus 1, and we're just going to go until we reach this condition. Now, of course, when we do reach that, we'll have to return true because it was a palindrome. So the while condition will break, and it will return true. But if it finds something fishy, it would return false. Amazing. This is a really valid solution for this, and if I run this code, you could see that it is accepted and everything. But let's give ChatGPT this problem and see if it could solve it even better than the solution that we provided. Okay, so let's go here and let's just see. This is a one for loop, and then there's this while loop. So give me a give me a really good solution, in C++ for the following problem. Okay, and we're just going to paste that in. So let's see. Now you could see that it actually used the clean string, and it's going, and it's also doing that same exact thing. Amazing. And it's going and checking all the cases. But this is actually the same thing. Can you do something better? And this is the same thing that we went through, but actually to use these operators like is alpha num, you have to use the cc type header file. So certainly here's an optimized version of the solution using two-pointer approach that reduces the number of string concatenations and comparisons. So meaning we don't have to do the string concatenations and comparisons, and of course it does it even better. So what we have is a left and a right, and we just go left right, so we don't have to do the concatenation, and we'd say left right, and the if number is alphabet, it would go plus left plus plus and right minus minus, and if it's not equal, it would just return false. So it's all doing all of that whole process that you saw in my lead code section, and it did all of that in some way inside of a single while loop, which is insane. I mean, that is a point for ChatGPT. We could give that point to it. But let's go to the last problem for this video. So the last problem is best time to buy and sell stock. So this problem is some sort of different problem, which we are given an array of prices where prices I is the price of a given stock on the ith day. So you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. So return the maximum profit. You can achieve this from this transaction. You cannot achieve any profit, return 0. So what you'd have to do is you have these prices. You could see this is an array, and what you do is this is the output 5, meaning that's the most profit that you got. Suppose these are the prices of a certain stock. Okay, you bought it in the first day, so it was $7, and in the second day the price turned into $1, and then in the third day it turned into $5. So we're not going from 0 index in this case, we're going from 1. So buy on day 2. So it says day 2 is actually this one. So day 2 is when it's only $1, and you sell it on, let's say 6, because it's what the price is 6 over there. So you do 1, 2, 3, 4, 5. So you do on day 5, price would be $6. The profit you would get is 6 minus 1, which is $5. Note that buying on day 2 and selling on day 1 is not allowed, because you must buy before you sell. So you can't just buy it, you can't just buy it on day 2 and sell it on day 1. That doesn't make sense. You can't have time traveling and go backwards. So we don't have that invention even existing, right? So that doesn't make sense at all. So let's try to solve this question. So let's go here, and what we're going to do is we're going to try to find the max profit. We have this prices, vector. So suppose we have this minimum price, and we also have this max profit, and we're going to have these two variables initialized. So I'm going to have minimum price, and this price would be, the price in that prices array. So this vector has some prices, but I want to find the most minimum price. For this case, I would just have the inner int max as the minimum price. This is the maximum number that an int could store, and now we'd have the max price. So actually max profit. So we'd say max profit, and that would simply specify it to 0. Now what would go down in, we're going to do it in a for loop fashion. I'm going to go from 0. I'm going to go, which is prices dot size function, and we're going to have the incrementer like this. Remember, you could have postfix like this, or you could have prefix like this. There is a little slight difference when this is actually added and then the expression is evaluated. But in this case, the first expression is evaluated and then it's incremented. So, you know, both will give you the same answer. So it really doesn't matter. That's just a note I wanted to give. Now, what I want to give here is that I want to check if my, you know, minimum price is actually smaller than the actually my current price, which is in the array. So the array, suppose the first number is 7. If that is smaller than this min price vector variable that I created, so I just say prices sub I. If that is smaller than the minimum price that I gave, of course it's going to be smaller because 7 is totally smaller than the max int max, right? What we're going to do is we're just going to update the variable and say the min price is equal to the prices sub I. So that's really good. We found a minimum price over here. But in some cases, it wouldn't work. And we would have, you know, something like, suppose this would also update. But in this case, 5 is not a minimum price anymore. You would have the minimum price as 1. So 5 is always bigger. So what you would do is you would put in the else case, the else if condition. And in the else if condition, I would check if the prices sub I, which is 5, if that minus the minimum price, which was actually 1, which I actually got from here. So suppose if 5 minus 1, which is giving me 4 profit, right? 4. If that is greater than the maximum profit I have here, which is like that. So let's see. Yeah, so I'm actually looking for that. Yeah, there you go. So if that satisfies, if the maximum profit, you know, is more over here, I would just update my maximum profit and I would just have the prices sub I minus the min prices. And this is just going to work around in one single loop. That's crazy. I really like this. So now we have this for loop exited after this. And if suppose we didn't somehow find anything, we could actually move out from this for loop and just return some simple max profit variable, you know, just telling us how much profit that was existed. Because if there was no such profit, it would give us 0. And, you know, 0 is the default profit. So that's why I set it there. Let's run this and we'll see that if it satisfies the solution and it is accepted, both cases satisfy. Okay, now what we're going to do is we're going to give it to ChatGPT. Can you give a better solution than the following problem? Okay, so I'm just going to paste in that solution that we wrote and let's see what it does. The solution you provided is already quite efficient with a time complexity of O of n, where n is the number of elements in the prices vector. However, if you're looking for an alternative solution, you can use a more concise approach using a single iteration and keeping track of both the minimum price and maximum profit. Here's an updated version. So it's saying instead of having these for loops, so one we'd have over here, and remember we'd have, you know, it was all in one single for loop, but it's just saying instead of, you know, keeping track of something like that, you would have to put them all inside like this. So however, if you're looking for an alternative solution, you can use a more concise approach using a single iteration and keeping track on both the minimum price and maximum profit. So it's just a little more concise. You know, it did that job for us. First, it had the minimum price, which is maximum, and the profit is 0. We go from prices all the way to the prices vector. So it uses this for each loop. If you don't know what they are, go check my video out. I have a video for this topic as well. So what we do is we get the minimum value and we say min price and the price. So minimum price is actually the, you know, the maximum, and the price is whatever's minimum. So you would get that 7 number, which is over here. You would put that in that min price variable. And in the max profit, you would get the maximum profit, which is 0, while minus the price minus the min price. So the price is actually the number, which is 7, and you have the min price, which is actually, um, 7. So you would just have the min price and you would put the maximum profit there. So again, there could be some more better touches, and ChatGPT just refines the problem. Again, this is the accurate solution. If I've done something wrong, you could always correct me in the solutions, but this version of the solution uses a range-based for loop, which can make the code cleaner and easier to understand. And keep in mind that the original solution and this updated solution both have the same time complexity of ON, but both are efficient in terms of finding the maximum profit from buying and selling stocks. Amazing. Hope you loved this video. Let me know what you think about this video. If you want more such videos just like this, then always let me know in the comment sections. Again, I will see you guys in the next one. Peace out.